Hello, everyone. Welcome to WaveTalkers Live. I'm Chris Mattia. My call sign is Whiskey 6 Alpha Hotel. Today, we're talking about portable solar power, and I'm joined by my esteemed colleague, Dan, NR6V. The two Davids are both out on assignment this week. And so it's just going to be the two of us as we work through some of the materials today, talking about solar power. If you missed last week for episode 34, we were talking about sizing your battery, and we started down a particular story with that. And we're going to continue that as we step through the process of looking at some of the options that are available and trying to develop some good understanding for that. So without further ado, let's jump into today's question. And that would be for everyone to go ahead and send in a WinLink check-in. Send it to all four of our call signs, KK60A, W0DHG, NR6V, W6AH, and to our tactical call sign, WaveTalkers, in the comment section of the standard WinLink check-in form. In the comment section, just go ahead and let us know what form of backup power generation you're currently using. Are you using maybe a gas or diesel powered generator or some other type of fuel, maybe using solar, wind, hydro? There's a bunch of different options. Maybe you're just carrying a bunch of extra batteries, or perhaps you're just going to carry the one battery that you've got and it'll be fine. So go ahead and let us know in that. And so let's go ahead and really quickly jump over to the PC and let's walk through that check-in process very briefly together. So all you need to do is make sure that you've got the latest version of WinLink. When you quit WinLink and launch it again, it'll automatically prompt you if there is a new update. And I know one was pushed out just recently, so you may want to go ahead and check that. Then what you're going to do is come over here on the left-hand side, click the new message button. That's going to open up the new message window. You're going to come in here, click the select template button right there at the top, right there under standard templates. Go ahead and click that drop down, and it should spring open this list of forms. Let's go today into the general forms. You're going to click the little plus next to general forms. Come on down to the bottom of that listing, and there it is, the WinLink check-in.txt. Just go ahead and give that a double click. If the demo gods are with you, it should open up in your browser of choice, and it should look something like this. You're just going to go ahead and click through each of these items. Look at that. It's going to add in the date and time automatically from your computer. This is going to be an exercise, and go ahead and let us know what mode or band you're connecting to us on, and what mode you're sending in your traffic. Here's where you're going to enter in all of our call signs and our tactical call. You put in your call sign, your station contact name, again, your call sign. Here's where you add your location, where you're coming in from. Make sure you put in the latitude and longitude so that you'll show up on the map at the end of the episode. And then here's that comment section. You can just go ahead and let us know what form of backup power generation that you're currently using. When you do click the submit button, there is an update to the forms, and it'll allow you to adjust the title of the form. You can leave that as it is. You don't need to change anything there. And then it should go ahead and populate all the information here. You just post that message to your outbox and then send the message however you send your messages via WinLink. I'm going to go ahead and click the open session button on my Telnet session here. I'm going to click start, and let's see if we've got any check-ins coming in. And it looks like there are check-ins coming in from all over the place. That's awesome. I'll go ahead and download those, and we'll be checking back in on these later in the show when we go and look at where everybody is coming in from on the map. So with that, let's go ahead and jump back over to our slides, and we'll continue down through the presentation. Now, last week, we were talking about sizing your batteries, and we really came up with the idea that it really is going to depend on your specific mission and your goals, the type of battery, the size battery that you're going to carry with you. But and to review what the mission was that we were trying to do, there were two stages to this. The first stage is almost always immediately establish communication. When you're going out in the field, whether you're doing a POTA activation or you're doing an MCOM activation, you want to establish communications right away with the other parties that you're trying to communicate with. And the second component of that is sustain operations for some extended period of time. Now, if you're doing a POTA activation or a summits on the air, you may just need to be on the air for an hour or a few hours. So your power needs may not be something for doing sustain. But if you're doing some off-grid, maybe you're on a long camping trip or a long hiking trip, you're doing an MCOM activation where you're going to be there for an extended period of time, this may come into play because we're not going to be able to carry all of the battery power that we're going to need to maintain all of our equipment for some extended period of time. And as we walked through last week's example, we were looking at this commercial radio, and with our 30 amp hour battery, just running at a 10% duty cycle, we determined that radio would only be able to operate for about 7 hours, which was far short of the overall time that we were going to need to do. I do see there's a question in the chat already about a link to the spreadsheet from last week's presentation. If you look in the email that went out with the announcement for this week, I've got a link to episode 34 up on WaveTalkers, and that has the spreadsheet there on there to dive into it. All right, so how long will it run? So what can you do if you need to extend the runtime just with the equipment that you have? Well, one thing you could do is you could reduce power. And when we're doing that duty cycle calculation, well, you could see very quickly that by simply reducing power, it will extend how long you're able to operate. You could also do things like use radios that are, say, QRP radios that are going to have a lower current draw both on receive and on transmit, and spend a little more effort on your antenna to make sure that your signal can still get out. Another option is to have additional backup batteries, carry some more weight with you. And that is certainly an option to be able to swap out. That's a quick, fast, easy way to be able to go. And the third one is to augment the battery power. And by that, we mean put in some other form of power generation that's going to create some amount of power and put some back into the batteries. Now, you don't have to put 100% back in all the time. That would be nice to be able to do. But as long as you're putting more power into the batteries, your total, the net effect is going to be a longer extended runtime. So when you're looking at portable power generation to keep your station on the air, ideally, we want to have, if we could, to have about 2 to 3 days worth of MCOM power, but that's not really always feasible. It's just the weight to be able to do it. In many situations, you might have to just grab and go, and you're just grabbing a very quick go bag that's going to just keep you going for a short period of time. So that may not always be feasible. The next is generating enough power to augment your NCOM power is the overall goal here. What you're trying to do is just be able to get enough power to keep yourself on the air. And your primary options there: fossil fuel generation, solar, wind, hydro. Of these different options, fossil fuel, that's certainly the easy one for a lot of people. You can just have a power generator that's running on either gas or diesel. However, let's say there's a big earthquake here in the Southern California region. More than likely, the roads are going to be blocked. You're not going to be able to carry that generator in with you. So you're going to have to carry what you have on your back. As time goes on, finding fuel is going to be more and more difficult. Solar is, for the most part, going to be available to you most of the time. The challenge there could be during fire season when you have really heavy, thick smoke and the skies are blocked out pretty well. That is going to be a little bit of a challenge there. Wind generation is definitely possible. It's possible to do in a portable situation. However, being able to set up and stabilize a wind generator can be a little tricky for a portable operations kind of setup. So it's not very likely to be used. Hydro is going to be very dependent on the area. Here in Southern California, we have enough problems with finding water, much less running water. Okay, so common types of solar panels and solar cells, and there are really three basic types. And again, we're going to be talking about portable solar here. We're not going to be talking about every different type of solar that's out there, but primarily portable solar. And there's really three basic types of panels. There are monocrystalline panels. Now, these appear black in color. If you look at the face of the panel itself, oftentimes you'll notice that there is this kind of like diamond pattern onto the cells themselves, and it's a little bit it's oftentimes a good giveaway that it's a monocrystalline panel. Price is another. These tend to be more expensive, and that's because each of the individual wafers of silicon are grown out of a single crystal. That would be the mono part, or one crystal in there. And that makes them a lot more efficient. So these are by far the most efficient of the portable solar power options that you're going to have. So you'll oftentimes, in a monocrystalline panel, you'll be able to get a little bit smaller size than you would in some of the other different types of modes. But you oftentimes are going to pay a little bit more for the quality over at least one of the other types, and then the third type is quite a bit more expensive. So that's the monocrystalline panels, and we're going to look at these in just a minute. The next one would be polycrystalline panels. Now, poly means multiple, and the way these panels are created is they take multiple little small silicon wafers, and they mash them all together. They bond them all together in order to create each individual cell. And one of the typical giveaways that a panel is a polycrystalline panel, it'll be very much blue in color, and it'll often have this kind of shimmery, iridescent kind of look. And you can really see that there's this different matrix of the wafers that are built into the panels. And we'll be able to look at these in detail in just a minute as well. Now, I will warn you that a lot of the panels that you get at some of the big box stores, the really cheap ones that are out on say Amazon and Harbor Freight and other places like that, many of those are polycrystalline panels, but they've been made to look like monocrystalline panels. So they'll often they may have a black tinge to them as well. So that's why the just look on the surface is not always the best giveaway for that. But it's a pretty good rule of thumb to be able to look at when you're looking at these. The polycrystallines are definitely the least expensive of the group, and they're also the least efficient. So usually your polycrystalline panels will be much larger panels for the same watt size. And when we look at the panels that I have, I've got a polycrystalline panel. Mine is a significantly smaller panel than the other ones that I have. So it'll be a little bit tricky to be able to see that. But these are the least efficient of the panels. The third type are called thin film, and these usually have a brown appearance to them, and there are some that have slightly different colors. It's a completely different chemistry that's used in order to create the solar panels. These are the least efficient of all three type. So you'll find that your thin film panels, you have a much larger surface area than you do for an equally sized, say, monocrystalline or polycrystalline panel. However, what you do gain by the thin film panels is they're flexible, they're foldable. You can stick them in your backpack, you can carry them with you, and you can just basically take them and throw them out on the ground. They're much more durable than the other two types of panels. They're significantly lighter. And so for a portable operator, these thin film panels, even though they're more expensive and they have a little bit larger surface area than the other two, they end up being kind of the ideal panel for portable operation for a lot of those reasons. So let's take a minute and we're going to do a quick demo here. And what I'd like to do is I'm going to switch cameras and I'm going to go to another spot. So it'll take me just a second to change this over. And let me see if I can make all of those changes happen. So I'm going to do this first. And now I got to change my microphone over to that microphone. And there we go. Now we're on location over here in the side yard. So the first panel that I have here, this is a 28-watt panel, and this is it's also by Bioenno Power. And this is one of those monocrystalline panels. You can see the look on this is it's a very black look to the panel itself. It's got four little sub panels that are all joined together in this matrix, and this is a 28-watt panel. But you can see kind of the overall size that this has. Now, one of the reasons that I do not have these panels that I'm going to be showing all set up is because I'm out of solar charge controllers. And with solar panels, anytime you do not have them plugged into either a solar charge controller, plugged into a battery so that they're the power is going somewhere, you want to keep them shaded from the sun, because as soon as the sunlight hits them, they start generating electricity. So this is the first of the monocrystalline panels. Let me grab another one here. It'll take me just a second to get this out. So this is a 60-watt power film. This is a 60-watt solar panel, and it just hinges open. It's got an aluminum frame that's on the outside of it. It's got little legs that open up and stand it up so you can angle it at the sun. But here you can really see it's a rigid panel. You see those diamond patterns that are in here. It's a very black appearance on the panel itself when you're looking at it. These are very efficient. It's a pretty small size just for these two, the two panels themselves, and it generates 60 watts of power, which is equivalent to about 3, sometimes even up as much as 4 amps of power that it's generating. So I'm going to close this one back up real quick because it's here in the sun generating some power. And over behind me, we have some other 60-watt panels, and these are also monocrystalline panels, and we'll look at those when we look at a slightly different demo in a second. The next panel I want to look at is the polycrystalline panel. Now, this is about a 21 or a 22-watt panel. This is an older panel that's a polycrystalline panel. And I think you can really see the blue color, and you see really that iridescent look, and you can see those individual little wafers that have been sandwiched back together in order to create the panel. Now, this is one that came off of the boat, and we used this to power the boat, and we had an array of 4 of these, and we would just strap them down onto the boat, and they generated all of our power that we needed to keep the boat operating well, keep the water maker running, our radio gear, GPS, all of the electronics that we had on board, and that's what we were using with these panels. But these are older panels, and they're actually not functioning right now anymore. But there we go. That's the polycrystalline panels. And the last one I have here, this is one of the thin film panels. This is by Power Film Solar, and this is also a 60-watt panel. But you can see already, look how much smaller that is. This can go right in your backpack or in your go bag. It's much easier to be able to transport in this format. The Power Film panels all have a watertight connector on it, and they've got a variety of different other connections. In fact, the camera that you're seeing me on right now is being powered by a Power Film solar panel. It's by one of the other panels that I've got. So let me open this one up so you can see the overall size of this. So you can see this is also a 60-watt panel, and you can see that brown color of the panels themselves. If I bring them up a little bit closer, it's a little bit easier to see them. And you can see this is all flexible. It's really easy to be able to fold up. You can toss it down on the ground. These have little grommets in the corner, so you can stake it down, or you can tie it up so that it can just hang, or maybe throw it over throw it over top of your vehicle or any kind of area where you need to generate some power. I'm going to fold these up real quick. Keep those out of the light. And I will head back over to the into the shade. All right. You able to hear me again over here?
We are.
All right. And was the audio working over there?
Absolutely.
Woohoo! Yay! All right. Love it when a plan comes together. All right. So now we're talking about how you wire your panels. So you can, of course, operate a single solar panel and work with just that one panel. But what happens if you need more power? You have a choice when you go to wire panels together to wire them either in series or in parallel. And there are some advantages and disadvantages to each of those choices. Now, first word of caution, wiring panels together. You want to make sure that you only wire panels together that are from the same manufacturer, that are the same size, that are the same make, the same style, all of those things, because the voltages can do some weird things. The power generation can do some very weird things with that. So the first one we're going to look at is solar panels when they're wired in series. And when panels are wired together in series, they add their volts together. So you get a higher voltage that is going into your solar charge controller. And we'll talk about solar charge controllers in a little while. But so when you series, you're going to add your volts together. The advantage here is that you can use smaller wires with that up to a point. But you don't need to go up in the gauge of wire quite so quickly when you wire your panels up in series. However, the disadvantage to wiring your panels in series is they are less shade tolerant. And I forgot one of my demo bits and pieces. So I'm going to have to make a quick run inside for a little piece for that demo for the shade tolerance thing. Okay, so that's the first one. And on screen right here, I've got a diagram that shows how you would wire panels together in series. Basically, you would off of each panel, you've got a positive and a negative. The positive on 12-volt systems are red, the negatives are black. And so what you would do is you would take from panel 1 to panel 2, you would run a single line from the red connection on one panel to the black connection on the second panel. Then you would take from panel 1, you would take the black connection, go into the black connection to the negative terminal on the solar charge controller. And on panel 2, you would go from the red terminal or positive and go into the red terminal. From there on, from your solar charge controller, you're staying with your standard red and black, positive and negative wiring diagram. But what this does is it links the two panels together in series. And we'll look at that here in just a second. Now, the other way to wire up your panels would be to wire them up in parallel. Now, in parallel, your parallel panels add their amps together, so it increases the current that is flowing through the panels. And that means you need to have larger wires to go along with that because you're pushing more amps into those at a time. Now, the advantage to doing this is that they are more shade tolerant. And we will look at that here in just a second after we look at the way that everything is all wired up here. I've got a diagram here that shows how you would go about wiring your panels together in parallel. Basically, you would join all of the red or all of the positive wires together, and you would join all of the negative wires together. And then those two wires would feed into your solar charge controller, and then you continue off with that wiring sequence there that way. So let's look at a little demo of that. So now I need to change that to there. We'll go to that camera. We'll go to this camera. And already you can see, before I even go out there in the sunshine, you can see that on the right of the screen, we have a single solar panel that's just connected to one of our systems. Then we've got two panels that are wired together in series. And you can see off to the right of those two panels, there you can see the wires that are going on there. So from the bottom panel, you can kind of see that the black line, or the negative line, is going directly into the panel in the foreground. The positive line from the panel in the foreground is going directly over into this right-hand side. And then the other panel, the other black line is coming up there. So let me go down and point those out. Oh, then here in the on the left is where the panels are wired up together in parallel. And those two have their individual, their pairs of lines that come up, and they're going to these junction boxes that are right there in the foreground, that are right to the right of where I'm sitting. And those join all of the red lines and all of the black lines together. Let me go down there and point that out a little bit closer, though. So let me change my microphone over to that. Okay, so here's the way that the panels are all set up. It's a little bit easier to see them when I'm down here a little closer. So this is the panel that is operating just as a single panel, and it has the two lines that are going out, and they're feeding up into a single solar charge controller. This middle section here, these are wired in series, and you can see the black and the red, positive and negative, that are coming off of here. The black line on this one is coming up, and it's going into the black terminal on the top panel. I'm sorry, it's going into the black that's going all the way up. The positive side is going up, and it's going into the black terminal on the top panel, and then the red line, the positive, is coming out, and it's going straight up and passing all the way through to the top at that point. So it's linking these two in series, which is going to increase their voltage. These two are operating in parallel, and you can see that each of them have a single line that's coming out of them. These are in case I wanted to wire up some extras in parallel here. And all of the black, or all of the negative terminals, are all ganged together. All of the red or positive terminals are all ganged together. And then those feed out in a single line that goes all the way up to the solar charge controllers. So let's jump up to the solar charge controllers and have a look at those. Okay, so in the solar charge controllers, here's the three of them that are all lined up. And so the one single 60-watt panel, all of these panels are all 60-watt panels. So we've got one single 60-watt panel going on here. And you can see the displays are rotating through. This battery is now full at this point. But it's just got the one panel going into the solar charge controller, and then that connects to the battery that goes up here. And you can see those are all labeled down here as well. Here's the one that's in series. And we can see on these two, this is the one that's in parallel. As they rotate through, they're pretty close to in sync, but we'll try and call these out. So this one's generating, that's at 13 volts. That's the charge on the battery. It's at 90% charged. Waiting for the, and of course, it's not pushing the amps in too, because it's also charged up. But we should be able to see the voltage when it comes around again. Fortunately, they all just cycle through. This one's doing 6.2 amps. There it is. This one's at 33 volts. So basically, they're like 18-volt panels. And so when you add the two together in series, you end up with the higher voltage. So this is running at about 32 to 34 volts, and this one's running at about 17 to 18 volts. You can see also the solar panel lines that are coming in here. This is the lines for the ones that are in series. They're much thinner. These are the lines that are coming in for the ones that are in parallel. they're quite a bit thicker gauge wire. So next, in order to do the demo, I actually have to run inside real quick. So Dan, can you check any comments that are going on for just a second while I run in and go grab the next bits for the demos?
You bet. Don't see anything in the chat, but anybody have any questions? Throw it into the chat. Yeah, a lot of RVers, full-time RVers are running 24 volt, some even 48 volt systems because of the ability to run a lesser wire size, a little more efficient that way. It's a little harder to set up, but with the lithium iron phosphate batteries that so many are going to, it makes it a little easier to do.
All right, sorry about that. So
the only thing that came up in chat, Chris, was somebody wanted to see, Michael KM5BOR wanted to see the kind of plugs that you're using for your solar.
Oh, okay. And actually you can see them all on screen right now. I use power poles as the standard connectors for all the panels that I have that are the monocrystalline panels are all by Bioenno Power. And for the most part, all of them, Bioenno ships theirs with these larger 50 watt or 50 amp power pole connectors. So these are the great big ones that you see on these. So right off the panels, off those 60 watt panels, this is the connector that's on there. And I've got a single one right here so you can see what they look like. And these all have both a positive and negative side, and it's oriented so that two of them mate together by simply connecting in the opposite direction. There's only one way you can put them together. And so when you do, the positives all line up, the negatives all line up, and they just snap into place. And that makes a good positive connection on those. So all of the 60 watt panels that I have that are the Bioenno panels all have these connectors on them. On the power film solar panels, stand by 1 second, let me go around to this side. The power film solar panels use these other types of connectors. They look like this, and when they mate together, they only mate in one direction. They've got little gasket seals inside, so it does make them as a watertight connection. They just clip together nicely, and then there's a release button you can press and just pop those apart. And so most all the power film solar ship with these connectors attached to the panels. When I got mine, I also ordered one of the because they didn't have any of the power pole connectors at the time. I got one of the just like 12 volt socket connectors, and I just cut the socket connector off and wired power poles onto it. Now you can order them. You can get power pole adapters for them as well. And let's see what else there's. Oh, on those 128 watt or the 28 watt panels, the little small Bioenno ones that I showed you at first, those use DC barrel connectors on them. And so when you order them, you get some extra mating DC barrels to bare wires. You can just crimp some power poles onto those when you're ready for them. So hopefully that helps with the connector types. Let me jump back to slides.
One of the nice things about Anderson power poles too is that the the cases are available in different colors, so you can color code them if you like. So your panels might be one color set, your loads might be another, and battery another, just to keep you from hooking it up incorrectly. Chris hasn't done
Yeah,
that, but
that's exactly what I did here, but I did that with heat shrink. So I put I make sure that especially on my solar charge controllers, the wires that come out that have the power poles on them, I put a little bit of yellow heat shrink on them, and you can see I write solar on it. And then for the battery, I've adopted green as the color for all of my battery terminals. So then I can look at that, and I can also see I've written on it battery, and then blue is what I use for load. And then I just have that written there on it as well.
Chris, there was also a question in the chat about what brands of charge controllers you like.
Yeah, we'll talk about charge controllers in a few minutes. We'll go into some of those for portable operation. So let me come back over to here. We're going to continue down this talking about series and parallel and some of the effects of shading on the solar cells when you have your panels wired in these different ways. So we've got our demo panel here, and we have our little shade block, whatever it happens to be. I mean, it could be a line, it could be a yogurt container lid. I don't know. It could be pretty much anything that's going to shade out your panels. So when you line your panels up in series, remember the volts are adding together. And so it looks kind of like this. And when you turn on if we think of these as water pipes, you turn on the water pipe, the water flows much faster. That voltage is pushing through really fast. If you wire your panels up in parallel, though, you get the same amount of water, and it's just dripping. It's just coming out a little bit slower, but you get a higher volume. You get that current that's flowing through at a higher rate. So you get your volts adding together, you get your amps adding together. So what happens when you apply the same amount of shading to your different panels? Well, if you apply the same block of shading to both panels, then the ones that are in series, it's going to restrict the overall flow of power to a much greater extent. Whereas in parallel, you have some additional redundancy that's set up. So even though this one section is still shaded, this line is still running at the same amount. And so your overall net current that you have of power generation ends up being a little bit higher. You're adding a little more redundancy. What's the drawback there? You're adding more current, which means you have to have bigger wires. Bigger wires, a lot more expensive in order to create those setups, a lot more weight to be able to carry. So it really depends on what your overall goal and your overall needs are. So with that, let's do a little demo. And for this demo, what I want to do first is show you that I have 3 yogurt container lids. They're pretty plain little yogurt container lids. And what I'm going to do is I'm going to go over and I'm going to shade the same part of one of the panels in each of our different tests. And then we'll look at the meters and see what they're doing to see what that effect is. So let's first switch over to this. And I'll go put these out there, and then I'll come back over here and we'll look at the meters. So as you can see, that's not a whole heck of a lot of shading that's going on those panels. But let's now switch over to this camera here. And I'm not sure if you were able to see them. This panel is running at 20 volts. This is the single panel. Unfortunately, the amps are not showing because the battery is fully charged. And we'll check these over here when they come around as well. And of course, this panel is also this battery is also topped up for us, which is not very helpful. What we should be seeing here is the voltage is going to drop, or the amperage is going to drop more in this panel than it will in the pair here. So this, we're still getting 4.8 amps out of the ones that are running in parallel. If I change batteries, this will, oh, there we go, 5. Now, of course, this is running at 5 amps, so it's showing the opposite of what we should be seeing. This is the challenge with running all of your stuff, running a demo overnight and making sure all of your batteries are all not charged up. So that's what there's where those are coming with that. All right, great. We have challenges. All right, let's go back to here. And turn that on. Okay, so let's talk about solar charge controllers and power systems that we have. Your overall solar system is comprised of 4 basic components. You have your solar panels, which is the obvious, these solar panels that are out there. You have your battery, which is also, we've talked about, you can operate your radio with just your battery, but you must have a solar charge controller. Let me repeat that. You must have a solar charge controller. Don't connect your solar panels directly to your battery. Bad things will happen. Don't connect your solar panels directly to your radio. Bad things will happen. You need to make sure that for your battery, the correct charge voltages are all going in at all of the right rates. The correct amperages are all going in at the right rates that are for the battery chemistry that you have. Now, many solar charge controllers all have different settings inside of them, so you can configure the specific technology of battery that you're going to be charging. So even though you may have that great old solar charge controller or battery charger that you have for that old boat that's sitting out in the yard that you haven't been out in a while, don't just go ahead and grab that and plug it into your fancy new lithium iron phosphate batteries. Bad things are going to happen there. The 4th component is obviously your radio, but really we should think of this as the load. The load is all of the combined components that we talked about last week. That is the overall net draw of power that you're using. So these are the 4 components. So with solar charge controllers, we're just going to look at some of the basics for MCOM. Again, these are always required. What they're doing is they're regulating the power that's generated by the solar panels, and it's managing the delivery of that power into the battery. So it's acting as kind of a traffic cop for the power to allow it to go in at the correct rate that your battery is able to take it in and charge with. It also prevents power from flowing out of the battery and back into the solar panels. Now, solar panels they don't have any intelligence built into them. So when the sun hits the panels, it generates a voltage on the different wires. All that voltage and power starts going then and flowing, and it flows towards the direction of the battery. But at night, if the battery has more voltage than the panels do, the panels are just as happy to accept that power and just radiate it back out as heat back into the universe. And so it ends up not being a very helpful thing. So all of your solar charge controllers have blocking diodes built into them, so they only allow the power to flow in one direction from the panels into your batteries and into the rest of the system. They also turned me off in the corner. For ham radio specifically, you need a solar charge controller that's designed for ham radio. You need one that is RF quiet. Solar panels get a lot of bad rap from ham operators about, oh, they're so noisy with this, that, or the other. Almost always, it has nothing to do with the solar panels. It has to do with the solar charge controllers and improperly shielded components inside of those that's generating a lot of that hash. The solar panels themselves are just moving electricity from one place to another. You need a solar charge controller that can handle the expected load of your radio on transmit. And this is a really big deal also. So last week when we were talking about sizing your battery and we're looking at that duty cycle, we brought up the chart that was saying how much power or how much current your particular radio was drawing on, say, high power transmit and how much it was drawing on medium power and low power. And not all solar charge controllers are created equal. For instance, let me jump over to, oops, I want to stay on this screen. So for instance, here's two different solar charge controllers that I have. This one is by Bioenno Power, and this one is by Buddy Pole. Both of them work pretty well. They're both PWM. We're going to talk about what that is in just a few minutes. But one of the biggest differences between these two panels, there's two big differences. One of which is this solar charge controller is limited out of its load port to only supporting about 15 amps of power, whereas the Buddy Pole Power Mini out of its load ports can support up to 30 amps of power out of its load port. That's a huge difference, because if you plug in, say, an ICOM 7300 and you're transmitting 100 watts on full power, this solar charge controller is not going to be happy if you have the radio plugged into the load port. Now, this is not a problem because you can simply plug your radio directly into the battery and have the battery plugged also out of its second port into the charge controller, and everything is working pretty happy. However, what you lose by doing that is a lot of these solar charge controllers have little displays, and they'll read out with the data that's going on. I don't know if you can see the data that's cycling through on these other ones back here. But when it cycles through the data, you lose that data for what's happening on the load port. Whereas for charge controllers that are designed in order to support the load typical for ham radio, then you can do everything all in one. So these are really nice. Of the solar charge controllers that I use, this is the one that I primarily use most of the time. It's the Buddy Pole Power Mini. The ones up here are much larger. They're not actually designed for ham radio, so they are a little more RF noisy. But the advantage to these is they can handle much larger loads, both in terms of the voltage and the power generated by the panels and flowing into the batteries. They'll support a variety of different amps. So this one's max current is 20 amps, and the max current on the load is 20 amps also. But these can handle a lot more voltage from panels going in, and they were a lot cheaper, so I could do demos with them. So that's why I have a whole pile of these for charging your batteries. You also don't need to worry if you're not running your radio off of the same system. So like, let's say you're setting up at an MCOM deployment and you wanted to create a charging bank, you could use some like this that are sitting there that not flowing noise into directly into the circuits that you've got. So it's those. Let's go back over to here. And I also mentioned you need to make sure that your solar charge controller can handle the expected load from the solar panels themselves. And there's two basic types of solar charge controllers, and you've probably heard these terms tossed around quite a bit: the PWM and the Mppt. Now, what the heck are those? Well, PWM stands for pulse width modulation, and Mppt stands for maximum power point tracking. Well, what is all that jargon? Okay, so let's start with PWM. PWM, these are cheaper. They act as simply switching a predetermined average current that's appropriate for the different battery technologies, and they just switch that little bits of current on and off. It's rapidly switching on and off, sending these little tiny pulses of power into the battery, and it's sending them at the correct voltages and everything. So it literally is like turning a light switch on and off, on and off, on and off. And it's the same measured amount that's going into the battery each time. The Mppt, maximum power point tracking, these are more expensive. They are highly efficient. Inside of them, there is a little computer, and it's got a little controller that intelligently manages the output of the panels with the voltage of the batteries in order to maximize the charging. Yes, that's a whole lot of mumbo jumbo in there that basically says there's some intelligence in there that's calculating the exact amount based on how much power is being generated by your panels, and it's feeding that into the battery at all of it out of the battery's appropriate levels. These are ideal for long-term operation. The longer you're needing to be out in the field, the more your long-term efficiency, the higher efficiency is going to matter. Why is the Mppt a little bit is it more efficient than the PWM? Well, over the course of the day, the sunlight is constantly changing. The intensities are changing. The sun is moving across the sky. The angle that your panels are pointed towards the sun is constantly changing. You can get fancy trackers that are tracking all of that. It's going to maximize all of that. But given if all things were equal, the Mppt is going to be more efficient in the long term. So for MCOM, does it really matter? Well, that depends on your mission. I mean, if you're planning on going out and doing a POTA activation or a SOTA activation, or you're going out for a long weekend to be out off grid, you're going to save a few bucks by getting a PWM versus an Mppt. Does it matter that you're not at peak efficiency? Maybe not. If you are deploying where you're in a mission critical situation for a long period of time, you're doing a de-expedition, you're going to be out for several weeks maybe at a time, you're counting every single volt, you're counting every single amp that you've got going in. So you want to make sure that the Mppt is something that you might want to consider for that. But in the long for the average just individual ham operator, does it really matter a whole lot? Maybe, but I've been operating with the PWMs for a couple of years now. I've not seen any issues of the charge controllers that I have. Some of these are Mppt, some of them are PWM. They all work roughly about the same. They are more efficient, but you're not seeing huge jumps in efficiency. So let's talk about connecting your solar charge controller. And here, order of operation matters immensely. You always, always, always want to start by taking your solar charge controller and plugging it into your battery, making sure that the battery boots up the brains inside of your solar charge controller so that it is operating and ready to go. Then number 2 is when you plug your solar panels into the solar charge controller. The charge controller will instantly read the voltage coming in from your solar panels, and it's going to start feeding that to the battery as at the appropriate rate. The third thing you're going to plug in is going to be your load, your radio, whatever equipment you're going to power, whether it's going to be your cell phone that you're going to go and try and charge up, whatever that happens to be. So you're always going to do it in this order. You're going to take your solar charge controller and you're first going to plug your battery in, then you're going to plug your solar panels in, and then you'll plug your load in. Let's review. Here's a Buddy Pole Power Mini. And one of the things that's really nice about this, you can see it's got this nice little screen that's telling you a lot of information on the screen here. You can see over on the left is showing you your system voltages, and that's the voltage currently in your system, and that is being generated by the solar panels that you have that are connected to it. You have the amps in and the amps out, or actually, I guess on this side would be the amps out, and on this side would be the amps in. So 3.03 amps in, that's pretty typical for about a 60-watt panel. You're going to expect anywhere from 3 maybe to 4 amps in good full sun for a 60-watt panel. Next, you have your net amp hours. Remember last week we talked about amp hours as a way to be able to calculate these things, and it's really convenient to be able to do that. So this is showing you the net amp hours that are being used by the battery and being consumed out of the load. This is showing you the net amp hours that are going into the battery system into the entire power system from the solar panels. And one of the nice things that a lot of these solar charge controllers do, if you have your radio and other equipment plugged into the load, is they're going to intelligently manage the power consumption, and they're going to tell you what's going on. This also has a little gauge here, and it's telling you that this battery, based on the set values that you've put in there, is roughly about only has about maybe a third of the power still left in it. So it shows you this kind of like little gas gauge, if you will, here on the side. So it's really nice when you have a solar charge controller that integrates all of these things very well, because it really does give you a more holistic view of what you have going on. So let's review the order of operations. Number one, you're going to plug your battery in, and notice it is the upper left port. The other thing that I really like about these Buddy Pole Power Minis is that they have power poles already wired on, and you can see kind of on the edge of this. I'll show you in the overhead cam that the power poles are actually color coded here as well. So you plug the battery in first, that boots the Power Mini up, or boots any of the solar charge controllers up. Next, you're going to plug in your solar panels. That's number 2 over here on the left. And then you would plug whatever your load is over here on the right. And power is basically flowing from the left to the right on these things. So let's go ahead and look at a demo for what we have here on the overhead. So let me switch back to this camera, and we have our battery set up, and hopefully the demo gods are with me. What I'm going to do is I'm going to use the single panel that's right here. I'm going to go ahead and I'm going to disconnect them in the opposite order. So if I had a load connected, I would disconnect my load. Now I'm going to disconnect my solar panels. And remember, you don't want to leave solar panels just sitting out in the sun when they're not being used. We're going to do a fairly quick changeover here, so I'm not going to worry about it too much for that. But so what we're going to do, and we're actually going to charge this 12 amp hour battery. So I'm going to disconnect the solar, and then I'm going to disconnect the battery. I'm going to move this guy up and out of the way. I'm going to bring in my Power Mini. The Power Mini, notice here's the solar, here's the color-coded panels, or the color-coded ports over here. So battery goes into the first one. So we'll start off with taking our battery. And I love these Bioenno batteries. They just come with the power poles right on them. And you just mate them up, plug that in, and we get the machine boot. It's got a little tiny beep, but I know it's a little hard to see on the camera. The screen on these is definitely not their strong suit. It's a little older. So then we're going to take and we're going to plug in our solar panels, plug those into here. And instantly what we're getting is we're getting 2.13 amps in from the solar panels, from that single 60-watt panel, and it's flowing into the battery. The battery is currently at 13.58 volts. The solar panels are at 13.6 volts. And underneath that is showing us what we have. If we had a load, we could plug that in over here. The other nice thing that the Buddy Pole Power Mini does is it has a little USB port over on the side, so you can actually charge a device out of this off to the side as well. So if you're using, say, this solar charge controller, the process would be exactly the same. Let me go ahead and disconnect these. Once again, we start off with the battery. Let's rearrange these a little bit. We'll take our battery, we'll plug it in to the battery port. Again, I use the green to designate that. We get the little screen lights up and it tells us what our voltage is inside of our battery. Next, we would go ahead and plug our solar panels in. And this one takes just a couple of seconds, and now it's gone ahead and it started charging. Not only do you have the load port on here, but you also have USB ports on here as well that you're able to charge from those. These work exactly the same basic process. So let me disconnect this. I want to show you one more thing while we're here talking about these. I'm going to reboot the Power Mini. Plug my battery in. Put that up here. And I'm going to also plug in the solar panels so that those are on charge. Move this out of the way for us. because I want to bring in another component that you may want to have. And this is something that we use with our, when we run the solar powered gateway. And for there, it's a mission critical setup. So we have our primary battery and we have our solar panels, and that's running into a solar charge controller. Then we want to make sure that we do not lose power. So we want a universal power supply for all of our equipment. And this is what's called the Buddy Pole Power Plus. And it has two circuits on it. It's got an A circuit and it's got a B circuit on the other side. And so you can plug your radio and other equipment into, say, one of these sides. The computer that's acting as your gateway, you can plug that into the other side. It also has USB ports that are on here. And one of the nice things, and this is not documented anywhere, but it works really well, is I just made a really small little patch cable that goes just from two different power poles. And you can plug the load of the Power Mini into there. And then I just have these are just literally, they're twisted. It's a straight through cable, but I haven't twisted so that it comes over. You plug that into the DC in on the Power Plus. That boots up. Now this is the Power Plus is now thinking that the Power Mini is just a DC power supply, AC/DC power supply. So it's taking that voltage that's coming out of the load port over here on the Power Mini, and it's acting just, like it would. So all of these ports are now active. They're live. I can plug in all of the load. But what I can also do is I can take a second battery. And when we're running the solar power gateway, we're actually using these larger 60 amp hour batteries, but I can take a second battery and I can plug it into the battery port here. And now the Power Plus is, I don't know if you can see the screen is lit up. All the power is going into there. Let's say this battery over here dies. We'll just disconnect. This is still staying open, still staying up and running because it's now drawing off of this battery. There's also a charge controller inside of here. So if there's voltage coming into that DC in port and you've got this set up, it's also trickle charging this battery as well. So with just a couple of really simple components, you have a complete system for being able to do and keep your MCOM station up and on the air all the time. It works really well. If you're concerned about PWM versus Mppt, currently the Buddy Pole Power Mini is a PWM charge controller. So if that's something that you're into, that's something that's certainly to keep an eye on. But the two components work extremely well. This usually lives on my gateway here at the house all the time. And I feed it. I have batteries that I run into this all the time, both a primary and a backup, so that my WinLink gateway is always up and running and always on the air. So that's kind of a quick look at a lot of these different components here. Let me switch back over to the slides, and there's we've somehow managed to go back through this. Oh, look, it's a little review. Yay. 1, 2, 3. There's the demo. So let's wrap up from last week. Last week, remember, we were talking about Baker to Vegas, and we were talking about this situation where the medic station was not able to keep the radio powered. So this is actually the night before the race. I had my 30 amp hour Bioenno battery was sitting here underneath of my solar panels. It's a good idea to keep your batteries out of the direct sunshine because they will heat up and bad things will happen. You want to make sure you keep them nice and cool. I've got the solar charge controller running here, and that was charging up the battery. And I have a pair of these in order to be able to operate. And so this is the battery that I deployed, and ended up, this was the overall system that I deployed at that station in order to keep it on the air. And so the medic station running this MRK radio was able to operate for well over 15 hours using that single 30 amp hour battery. And I just had the solar panels that were deployed to keep the battery topped up at what's called float, keeping it right at the proper charge level. So it was always ready to go. And this image, we looked at this last week when we were talking about the little, let me turn this back on here. we were looking at this display last week. This is the PowerWorks little meter. And what you may not realize is this is the actual data. So after we had the radio operating off of that 130 amp hour battery, when I got back to the hotel room late that night, I plugged the battery in and I plugged this meter in line between, I set the source to be the charger, the AC charger, and I set the load to be the battery because I wanted to see how much power we actually drew out of the battery for that whole 15-hour day. And it ended up being, we only drew 5.206 amp hours out of that 30 amp hour battery. So we could have continued to operate for quite a bit longer, even though it was well after dark. And that was simply because the solar charge control, the solar panels were backing that battery up. So with that, let me switch back over to just me in here, and we'll bring Dan up to screen. Oh, actually, let's check the map real quick. Let's do that briefly while we're here. Let's do some checking because we're up at the top of the hour. Let me do another quick check of the check-ins that have come in, see if any more check-ins have come on. Oh yeah, look at that. There's more that are coming in. Wonderful. Go ahead and check those. See what the overall ones are. And we'll do one more quick check as soon as this finishes, just to make sure everything came in, make sure everybody's on the map. There we go. Do one more quick check. What the heck, just to make sure. Yep, see, there's always one. KM5BOR, we got you. There you go, coming in there. Perfect. We'll even do one more. What the heck? All right, it looks like we got them all. All right. So in here in WinLink, I'm going to click on the little map icon right there. It's going to bring this up and select from. We're going to click the drop-down menu. This allows you to select any of the different WinLink check-in forms that support the mapping feature that you have received one of those forms. I'm going to select the WinLink check-in because that's what everybody just sent in. There's lots of other options here for you to choose, but I'm going to go ahead and display the map. And let's go ahead and put this out to, let's first check the filters. And filters are set, so it's only going to show us the any of the check-ins that have come in the last 10 hours. Go ahead and hit save for that. Let's blow that out to full screen. And we'll zoom out to look at the overall view of the planet. And there we go. Look at that. Oh, we got three check-ins coming in from Europe. So Franz and Roland, you've got a friend here. Oscar Echo 1 Lima Hotel Papa. Hey, thanks for joining us. And we also have Terry down here in New Zealand, ZL1 HOG. A couple of folks out here in Hawaii today, Bill KH6UU and WH6FQQ. Thanks for joining us. Let's go ahead and zoom in on the continental US here and see what we've got. I did get a note from our friend in Canada who normally joins us. They were on the road today and weren't going to be able to join. They're going to watch later on the stream. Looks like WA1 URS up there in Bangor, Maine is joining us. Good to have you with us. W4 RJG. KG0OPX N2 AWE. We got down here in South Carolina, KO4L. Thanks for joining us there. KO4PFV. Who else we got down here? KM5BOR, K4PPK, KO4QHN. Oh, this looks like John, KC5LAA. There you are. Some friends in Wisconsin and Iowa, KOHAL and KE0CBV. Excellent. Let's just jump around here real quick. A couple of more. And I see Bill up there, friends in Idaho coming in, folks all over California joining us, N7GET coming in from Vegas, and then a whole bunch here down in the Los Angeles area. So excellent. Thanks for checking in with us. We are thrilled to have you. I'm going to switch back over to here. We'll turn that off. We'll bring Dan up the stage. Where'd you go, Dan? There you are. Add the spotlight. Hey, Dan, what kind of closing thoughts you got for us for today?
Well, first of all, I want to thank you, Chris. I've been a little under the weather, and I think I'm headed to healing now. David and David have both had outside commitments. So Chris has carried almost the entire load, if not the entire load, the last 2 weeks. So thank you, Chris, for stepping up and doing that. Great demos today. You look in the chat, there are folks that agree with me on that. And I know it's not easy and probably not all that comfortable out in the sun. So thank you for that. And I learned a few things, and that always makes it worth the time.
Excellent. Thank you very much. I've been operating, and I also gotta give a big shout out to both Bioenno Power, who has supplied us with most all of these batteries and solar panels. Power Film Solar has supplied us with several of their panels and some of the accessories as well. And Buddy Pole also with their solar charge controllers. So we reach out to these folks and we say, hey, we're trying to teach people how to do some of this stuff, and we want to put together some big demos to be able to show this stuff off. And so they're gracious enough to send us some of this equipment. So I certainly couldn't afford to buy all of these things all myself. But it helps really to be able to step through to build out a lot of these demos where we can show some of these comparisons to be able to do. So a big thanks to all of those folks. And the stuff that we do buy, so half the solar panels that we have from Bioenno Power and half the solar charge controllers we have come out of the coffee funds that come from all of you who help support us there. So if you like what we're doing, if you find it very helpful, then please consider going on to the WaveTalkers website. We've got that buy us a coffee link, and just go ahead and do that right down in there. Any little bit helps, because it helps to cover the gear and some of the setup and so forth, and it really helps keeping up all of this infrastructure that it takes to bring the show to you live. If that's not your thing, no big deal. What would be really awesome is if you could go on to our YouTube channel. Just go to youtube.com/WaveTalkers. Subscribe to us there. Like some of the videos, like the content that's there. Share it with your friends and share it with the folks that are joining you at your various meetings. Bring them along. Also, if they sign up on our Join Us mailing list, we'll send out the email every week to join us live here in the Zoom. We're going to be going to the after party here in just a minute. And if you join us live in the Zoom, you're able to hang around for the after party, where we invite everybody to unmute their mics and join in. So I certainly have a lot of fun doing all of the solar panel and solar powered stuff here. I think it's really critical skill to have for any portable operator and any person involved with emergency communications to have at least some basic knowledge of. So with that, I will say thanks for joining us, everyone. If you're here in the Zoom, hang around for the after party. I'll say 7-3 as soon as I go over and find where all of the turn everything off. There's the window. So thanks a lot, everyone, for joining us. 7-3, and we'll see you next week.